Hi, in this video we're going to find an unknown angle in a trapezium. Now remember, trapezium is just a quadrilateral, a four-sided shape with straight edges where you have a pair of parallel sides. Now we've dealt with trigonometry, which involves right angle triangles, but there's not explicitly a right angle triangle here. But what we could do is we can add a side length to make a right angle triangle, so we can then use trigonometry. So if I was to add, say, a line like this, that's going to give you a right angle triangle. And what we could do is that if we could find this angle here, then because you know that's a 90-degree angle, because that's horizontal, that's vertical, so that's a 90-degree angle, you can just do 90 plus that angle, and that would give you that whole angle theta there, right? So that is a right angle there. Let's just put that in to remind ourselves. And we want to find this angle here. Now, we don't know what that angle is. Let's just call it x, just to give ourselves something to use. Now, what do we know about some of the side lengths in this diagram? Well, we can see that is 7 here. So that length is also 7. So let's put the 7 in. But we also know what this side length is, because look, this whole thing is 14, but this is 9 here. So if that's 9, what do we need to make it up to 14? Well, it's 5, isn't it? So that length is 5 millimeters. And now we can use this triangle to find x. So let's just draw it out separately. Got the 5 at the top, 7 here, and the x, the angle we want. So remember, we label the sides relative to the angle of interest. The angle of interest is just the labeled angle, which is not the right angle. So this side here is opposite that angle, so we call it O for opposite. And then this side here is adjacent to, next to that angle here, and it's not the hypotenuse, it's not the longest length, so this is the adjacent, A. And then remember, we use SOHCAHTOA to work out which trigonometric ratio to use. So we can see we're involving the O and the A. O and A is here, so it's this one here we're going to use. And that is short for, which we've previously seen, tan of theta. T is for tan. Tan of the angle of interest, theta, is O over A. And the theta is the angle of interest, which is this here. Okay, so let's just substitute in. We've got tan of theta was x, is O over A, so 5 over 7. Now we're trying to work out x. We need to get rid of this tan on front of the x. So to do that, we do inverse tan of both sides. Tan to the -1, we write it as, and that allows us to get rid of that tan on front of the x. So the inverse tan gets rid of that tan, leaving just x. And then we're going to do inverse tan of the right-hand side as well. And we do shift tan on our calculator of 5 over 7. Depends on how your calculator works. We get 35.5 degrees. Okay, right. So we now know that this angle here is 35.5 degrees. But we also know that we've got this right angle here. That's a right angle. So the total angle theta is 90 plus the 35.5. So we just need to add the two. Theta is 90 plus 35.5 degrees, and that is equal to 125.5 degrees. And that is our final answer. It's 125.5, and we're done.